Today we are talking more about quadratics and parabolas. We're going to be using our calculator on a lot of what we're doing today, but not all of it. Tomorrow we will really move into the vertical motion problems. So most of the calculator stuff that we're doing today, I have already been showing you along the way, just to make it easier when we got to this point. So copy this equation down, y equals x squared minus 6x plus 8. We're going to read what we're asked to do. It may or may not be calculator on any given problem on this assignment today. Complete the square. That's no calculator. To find the vertex and then sketch a graph. And answer whether the vertex is going to be a minimum or a maximum. So we totally review here. So Allie, help me with completing the square. How do I get started? So y minus 8 is x squared minus 6x. Jack, help me complete the square on this. And then Griff, if I FOIL out x minus 3 times x minus 3, what do I need to put here? And if I do that, what else do I need to do? And is it really a plus 9? Is this really a plus 9? Did I have anything out in front of a parentheses, a GCF that I'd factored out? But we're getting in the habit of we're making sure it really is a plus 9 here, because if I factored anything out, it was just a 1 in front of all of that. And so I do indeed add the plus 9 there. So that gives us y plus 1. So y is x minus 3 all squared minus 1. Cooper, what's my vertex? So far, so good. Is that one going to open up or down? Everybody point. Will it open up or down? So everybody's pointing up. It does indeed open up. Does that mean that it will have a minimum or a maximum for its vertex? Abby. So if it opens up, will the vertex be the maximum or the minimum? Will the vertex be the highest or the lowest? So it will be a minimum. And when it's written on a worksheet paper or problem set paper, you can just circle it to answer it. You don't have to recopy that. So if we want to graph this thing, we have 1, 2, 3, -1. And I know this would be my axis right here. And do I know a y-intercept? Wyatt, you're nodding your head. Yes. What's my y-intercept? 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And by symmetry, I would have a point over here. What about my x-intercepts? Where's the easiest place to get my x-intercepts? Who remembers the best line to look at to get those? Easiest place. What's going to be the easiest place to get y is 0 and then x is something? Come on, somebody remembers that. What's the easiest place to go for that? Caleb? Almost. Let's go one above that. It's actually slightly easier, because if I plug in right here, I already have 1 equals. Otherwise, I'd have to bring it over. So 1 equals x minus 3 squared. Parentheses squared equals. What do I do to simplify parentheses squared equals? Nicole, what do I do when I have parentheses squared equals? Square root is what you're drawing in the air. Square root of both sides. And when I do that, what do I have to remember? Plus or minus. What's square root of 1, everybody? So this says plus or minus 1 is x minus 3. So x is, add the 3 to both sides. 3 plus 1, 3 minus 1. So x is either 2 or 4. So my x-intercepts are 2, 0, and 4, 0. And so that would be here and here. And then I have my 5 points, so I can draw my parabola in here. Questions with that one? Okay, next one. It's going to be the very same equation, y equals x squared minus 6x plus 8. This time, we need to do it by factoring. So we're going to let this be a 0 because we're just trying to get the x-intercepts. And I need some help factoring that thing. Who thinks you've got it? Kit? X minus 4 and what else? Does that work if you FOIL that out? And that would mean x minus 4 is 0, so x is 4. X minus 2 is 0, so x is 2. Are those the same numbers we got on the previous slide? So factoring, completing the square, we got the same x-intercepts. We could do it, but we're not going to put it in on the calculator as let that be f1 of x. And then the calculator would give us this. What would we call it if we were trying to find those with the calculator? What word does the calculator use? Menu, analyze, graph, zeros. And we would have gotten the 2, 0 and the 4, 0 right there. So they would all match up. All 3 ways would give us the same answer. Yes? Did it say to? Did I miss that? No, it did not say to do that. We could have, but would the discriminant have been positive, negative, or 0 if we had done that? It would have been positive because we had to. And since that's a good question, let's go ahead and calculate it real fast. Discriminant is just b squared minus 4ac. What's b in my equation? Negative 6. Now, b squared means b times b. So that means negative 6 times negative 6. It is not like this. It is a positive 36. And then we're going to subtract 4ac. So let's see, what's a and c? So 4 times a times c, 36 minus 32. The discriminant is 4. It was a positive number. We did have 2 x-intercepts. We do have 2 real solutions when we set it equal to 0. All right, next one. This time we are going to use the calculator. First, and you do not have to complete the square on this, so you do not have to factor something out so that you start with x squared. First, everybody point. Will this one open up or down? So everybody sees the negative 2 in front of the x squared, so we know it's going to open down. Will this one have a max or a min? This one will have a max. So punch that in on your calculator, and then menu analyze graph. I want you to get the max, menu analyze graph, get the x-intercepts, and we will draw a little bit of a sketch. So does mine match what you were finding? 1, 5 for the max, and negative 0.581, comma 0, and positive 2.581, comma 0. Now, on all of these, whether it specifically says it or not, I want you guys to draw a sketch. So first thing, 1, 5, they are both positive. So the max vertex was at 1, 5. That's in the first quadrant. So I'm going to make sure I have a dot in the first quadrant. And I may change the scale a little bit. If my calculator looked like it was real close to the y-axis, I'm going to move it over when I draw my sketch. Now, it also says one x-intercept is negative, the other is positive. I am not going to draw my parabola really skinny like that because I just drew 2 positive x-intercepts. Do you see how both of mine are on the positive side? So that would not be correct. So I would instead be drawing it so that it comes down like this. And then I can label everything on the graph. That is 1, 5. This is 2.581 comma 0, and this one is negative 0.581 comma 0. On our quadratic applications, always draw a sketch and label the points that are asked about in the problem. Everybody good with that one? Okay, last one then that we're going to do today. And this is a word problem and requires a little bit more thought. Tomorrow we'll do a lot of vertical motion. Profit is often a quadratic. You start up a company, and at first you're not even making a profit because you've had to spend so much on equipment and getting everything ready to go. But then after a while, you start making more and more sales and your profit goes up. But then a lot of times it kind of starts to drop off again. At first, you've got a brand new product nobody else has thought of before. You're the only one selling it. And so you have people, that is a fabulous idea. As soon as they hear about it, they've got to have one. And then everybody that's got to have one has one. And so maybe there's not quite as much demand. But also maybe somebody else said, that was a really great idea. We're going to do something almost the same. And you got competitors. And so you don't get all of the market. So very often it's true that the profit goes up, and then at some point it peaks, and then it starts to taper off. That's what's going on in this example. So they give us this equation, and they say the profits are in dollars, and they say X weeks. So X is in here, it's the independent variable. That means when we do draw a graph, this is going to be the number of weeks the company's been operating, because the X is right there. That's where the independent variable goes, and they tell us X is weeks. They also tell us the other one, profits. So they could have put a P here for profits. So that tells us the y-axis will be profit. And you are expected to label the X and Y axes with whatever words go with the problem, if it's not just an X and Y like that last example. So far, so good. Okay, everybody point. Will this one open up or down? It's going to open down. Tell me the vertex. Is it in vertex form, hint, hint? Is it in the form where you can look at it and tell me what the vertex is, Yo-Yo? What's the vertex? So we better get 12,630 when we graph this. So do it on your calculator, just for the good practice with that. Recording. So I got this blank screen, and yet I know that my vertex needs to be at 12,630. So I need that window to go a lot higher than 6.43. I can do menu and then 4 for the window zoom. I could do 1 and enter by hand what I want to guess for the dimensions. I like to try choice A, zoom fit, and see if that helps me. Hey, that looks like I'm seeing part of it. But it doesn't look like I quite get all the way up to the top. So I really need to go a bunch farther out to the right. So now I probably need to go at least twice as far out to the right. Now, because I can't really see these down here real well, to click at the bottom and change the X dimensions, I am going to do menu, 4 for window zoom, 1 for the settings, and I need to go a lot farther to the right. It went to 10. I need to go at least twice that far. I'm thinking I'm going to type in 50. And for my Y's, I really like to get my axis in there. So I'm going to go down, I don't know, how about negative 20 for a minimum, and maybe a little bit higher for my max. Maybe I'll do, how about 700? Bunch of things would work. That's just what I'm happening to pick. Sure enough, that's big enough. Now I can see my vertex. So do menu, analyze graph max, and make sure that we get the same vertex that we are expecting from the vertex formula. So we can do the menu, analyze graph, max, left and right, and sure enough, it's the same thing. I'm going to draw a sketch. I'm noticing my y-intercept is something positive, but this did not ask me for a y-intercept, so I don't have defined that. What I am going to do when I draw my sketch here is it's going to have a positive y-intercept, and then it's going to come down, and this is 12,630. That's the only point that this problem asked me about. If it had asked me for a 0, when does the profit get back down to 0? I would have found this point. If it had asked me, what's the profit when we first start out at 0 weeks, I would have found this point. Now, what it does do, and we said this was a maximum, what is that value? The point is 12,630. The max is what is the highest y? What is the highest just y that this graph ever reaches? 630 is the max value. In the context of the problem, that means explain both variables. That's going to be a complete sentence. Now, what we have is the x's are weeks, the y's are profits. So for any point on that, whatever the x coordinate is the number of weeks, and the y is that's the profit at that point in time. So if I knew this point right here, I'd say at this many weeks, here's the profit. For the max, it means the max profit is 630 with units dollars, and it is reached at 12 weeks. So you see how that explains both variables with words, with units. I'm not sure I'd want to start up a company if it's going to reach its maximum profit after only 12 weeks. I'd probably want it to, keep improving and improving for a number of years if I were going to start a company. Questions from anybody? Well, I don't know if you're only going to put, maybe if you're only going to put in $5 and then that's your maximum weekly profit. It would depend on what your startup costs are, but that's exactly the kind of analysis that you'd be doing. You'd be doing a cost analysis. Is it effective? Do you get an effective rate of return relative to what all you've invested?